ran a couple of baselines. So I'm a very minute part of this whole thing. So I'm here to, so greetings board, president, trustees, superintendent, Turkey, and community members. I'm going to read from a script. I know Adriana speaks from her heart. She made that clear. She doesn't use scripts, but I'm going to use a script. I'm going to use a script for the sake of brevity so I can stay on track. So last year when I worked at the district level supporting all sites, I met our math passionate Elkhorn parents, Mr. David Margulies, while I was modeling best practices in classrooms at Elkhorn. And David was there. I was modeling and for the teachers and the students, and David was there to work with small groups around math fluency. Surprise. We spoke afterwards, which led to our shared understanding of the importance of ensuring student math multiplication fluency and meeting that prerequisite foundational skill in order for students at higher levels to have the confidence and skills to access that grade level content. This is a century-old problem. We noticed the gaps. We commented the gaps in math fluency. And I've been, outside of the classroom, I've been overseeing curriculum and supporting teachers and hyper-focused on data for 12 years. And I did notice that gaps in math fact fluency is a main impediment to student math confidence and stamina and success to reach grade level standards. So we decided to quantify it, which we did, to measure it with concrete data. I pushed into, this is my little piece, so I don't know why my name's at the top, but I pushed into all the classrooms and into Castroville classrooms to gather math multiplication fluency across grades through 4 and how it correlates to student success on the CASP. And then Mr. Margulies has more on this. So that's how it has.
Great, Gigi, thank you so much.
You could put the mic back. They'll adjust the sound.
Yeah, so I'm going to be talking about math fact fluency, and I greatly appreciate the opportunity. Okay, so yeah, this covers work done with Gigi while she was district TOSA. My perspective comes from speaking with teachers and as an in-class volunteer for the last year and a half working directly with students on math, where I repeatedly encounter the refrain, students do not have their math facts memorized and it's holding them back. Our state standards are explicit in their direction for memorization. Standard, by the end of grade 2, know from memory all sums of 2 one-digit number. By the end of grade 3, know from memory all products of 2 one-digit numbers. So math fact memorization is not a new suggestion. It is in the standards. It is what we are expected to teach, and it is supposed to be accomplished by the end of grade 3. Nationally convened expert panels on math instruction emphasize the importance of automaticity with math facts, and they reach their conclusions after an extensive review of the literature as they describe in their reports. The Federal Institute of Education Sciences in their practice guide says, quickly retrieving basic arithmetic facts enables students to follow explanations of new ideas and have more mental energy to understand complex tasks, concluding building automatic fact retrieval is an important goal of intervention. The National Mathematics Advisory Panel in their 2008 final report state, computational facility requires the automatic recall of addition, subtraction, multiplication, and division facts. So if our professional development does not emphasize automaticity, then not only it is in contradiction to these reports, but it is ignoring the vast body of cognitive literature that is supporting these reports. So you should question whether it is evidence-based. There are 5 reasons why research shows math fact fluency positively impacts learning rates. 1, increased rates of practice. This is simply a fluent student finishes more problems in a given time, so more opportunities to respond. The more problems you can do, the more practice you get, and we all know practice makes perfect. I see this all the time, like with a worksheet on factoring, an essential skill for finding common denominators and working with equations. A fluent student will finish the worksheet in like 3 minutes, while a non-fluent student will take like 20 minutes and not be accurate. Also, the CASP-like problems are often at the worksheet's end, so a fluent student practices more of those. And skipping the foundational skills and going straight to the CASP-like problems is not a path to success. Fluency gives more efficient learning, and comparing multiple problems in a short time frame enables connecting skills and strengthens conceptual understanding. 2, increased rates of reinforcement. Successful problem solving is reinforcing to a student, confidence building, something we can all relate to. Less effort is required to do a math problem. Worksheets, homework become easier. Students are more likely to start, engage, persevere through, and finish a task that is reinforcing. 3, cognitive load. And this relates to how students think and learn. It refers to that working memory is limited, something we can also all relate to. Think of cooking and trying to follow a recipe while someone is speaking to you. You say, wait, I'm concentrating. And this is your working memory completely occupied trying to follow the relatively simple recipe. So when problem solving, if a student's limited working memory is occupied calculating simple math facts, problem solving may be inhibited. For example, I was working with a non-fluent 6th grader on a performance task involving how many times 7 goes into 31. She considered this using the strategy she had been taught to figure this out without math fact memorization, and after 20 or 30 seconds said 4. So I said, okay, continue with the problem. She looked down at the problem and said, I forgot what I was doing. And this is because her working memory was completely saturated calculating simple math facts, and problem solving was stopped cold. These facts need to be pulled from long-term memory. Fluency allows isolating a new skill, not using a procedure to figure out a prerequisite skill to practice the new skill. 4, fluent students are more likely to maintain skills. 5, generalization. This allows quantification of what know from memory means. Generalization means a student can apply knowledge of a learned skill to learning a new related skill. So for example, addition to subtraction. And as Angelo described, his algebra students struggled with negative numbers, a concept essential to working with equations. So if a student knows 7 minus 3 is 4, can they generalize to minus 3 plus 7 is 4? And fluent students can do this because research indicates students need to be above 40 digits correct per minute answered on a math fact fluency test for generalization to occur. Lastly, we all want to be inclusive. Fluent students are more likely involved in the math conversation. So any of these reasons by themselves is powerful, but all 5 taken together is why math fact fluency is a hugely important foundational skill. Okay, so where are we? Gigi did the following multiplication fact fluency assessment. All products of digits 1 through 10, 100 products, 5 minutes, 3 seconds per product. Students need to be at 35 digits correct per minute to finish this test. This is slightly lower than the generalization threshold, which implies this test sets the bar slightly low, and students should be able to do this test. Here are the results for one elementary school, grades 4, 5, and 6, plotting products answered correctly versus percent of students at or above that point. Look at grade 4, the orange squares, starting at the lower left. 10% of students answered 100 problems correct. Going up the curve to 99 and 98, you see 20% of the students answered 98 or higher problems correct. Then further up, you see 27% of students answered 96 or higher problems correct. So although we want our students to be at 100%, students can make 1 or 2 silly mistakes. So don't place too much emphasis on the difference between 100 and 98. But when you get down to 96, you have students who have made errors or are slightly slow. But with a little work, this is fixable. Therefore, we say at 96 problems correct, the student is at or approaching fluency. Then you see very few students at 93 to 95 and then a gradual tail. So there is a natural threshold at 96 distinguishing fluent and not fluent students. So 25%, only 25% of 4th graders are fluent. And note that this test was taken at the end of the grade. Students are expected to be fluent at the end of 3rd grade. 70 to 75% of 4th and 5th graders tried to learn math without being able to take advantage of all the benefits that research shows fluency provides. 60% of students enter middle school without fluency. Students need help achieving this standard. Next, we plot accuracy versus percent of students at or above this point. Looking at the lower left, 30% of students are 100% accurate, and this can be 72 out of 72. 60% students are 97% accurate or higher. 80 to 90% of students are 90% accurate or higher. So although we have some students who struggle with what multiplication is, and this is a big concern, in general, students are accurate, just not fluent. This again plots products answered correctly versus percent of students at or above that point, like the first plot, fourth grade, but now all 4 elementary schools. So this plot is similar to the first plot. All schools are similar, so fluency is a district-wide issue. Is math fact memorization just one of the many standards students are expected to know, or is it a big deal foundational skill affecting our CASP results? This shows the actual CASP scale score with corresponding CASP levels 1 through 4 shown as a function of products the student answered correctly. I also mark a level 2.5 to discuss students nearing proficiency, the borderline or bubble students I often hear mention of, who with just a little intervention could become proficient. I will show a series of plots to guide you through this quantitatively. I have broken this plot into 3 regions: students who answered less than 76 products correctly, students between 77 and 95, and the fluent students 96 and above. So look at the region for 76 and below, to the left of the line, and ask how many students have scored above 2.5. 0. 0 out of 29 students who answered below 76 products correctly scored above 2.5. In the regions 77 to 95, 25% of the students are above 2.5. And in the fluent region, 63% of the students are above 2.5. So where would you like students to be to best position them for success? In terms of correlation, the numbers speak for themselves, but to quantify correlation, we can look at how well a line fits the data as measured by the correlation coefficient R, which is 0.65 out of 1. So depending, this value can be considered strong correlation or moderate. However, this is a ceiling limited test, meaning there were a fixed number of problems to answer. Our fluent students, circled, finished the test in 3 to 4 minutes. If they had more problems to answer, they would have, which would have moved their points to the right, better fitting the line, increasing the R value, meaning this R is actually an underestimate to the correlation in this data. Okay, there are some students who are fluent, the circled ones, yet struggled on the CASP. Why? To understand this, we looked at the role reading plays in math. We have separated the students into those who scored ELA 1, the open circles, and those who scored ELA 2, 3, and 4, the filled circles. The open circles tend to be lower than the filled circles, indicating you have to read well enough to understand the math problem to do well in math. Note that the students who are fluent but did poorly on the math CASP are struggling readers. So it is possible that the reason they are struggling in math is simply because of reading comprehension. Now we separate the students into 3 groups: ELA 1, ELA 2 and higher, and a third group, the red triangles, who are ELA 2 and higher and fluent. 85% of these students are 2.5 and higher. So if you can read well enough and you are fluent, you are in a group that achieved reasonable success at a very high rate. So this begs the question of, if you got all students fluent, would you improve the proficiency rate of the not fluent ELA 2 and higher students below 96, currently successful at a rate of only 14%, to 85%, basically doubling your proficiency? In the interest of time, I put the plots showing the data for 4th and 6th after the presentation and made this summary slide. The top table summarizes the 2.5 and above group. You can see in the left column, students below 76 struggle on the CASP, especially in 5th and 6th. And on the right column, fluent students in 4th and 5th have a high rate of success. Two questions arise. Do the students who achieve success in 4th grade without fluency maintain and generalize their skills to 5th grade? The data indicate they may not. Also, the data indicate fluency needs to occur earlier than 6th grade. What can we do? Math fact fluency needs to be a district focus. We need teacher buy-in, so teachers need to be made aware of the research on why fluency is so important and the data. Then we need a program that requires minimal class time, and it would be great if it were free. This exists, the Facts on Fire program. It meets students where they are and scaffolds them to fluency. All 4 operations, benchmarks, and assessments. 4 minutes per day. To wrap up, I want to point out that fluency is consistent with our LCAP goals. We particularly want to avoid a situation where non-fluent students are unable to take advantage of all the benefits research shows fluency offers day after day, causing a snowball effect in their learning, leading to disparities. I want to relay a conversation I had with a parent in this district. Her 5th grade son did not have his multiplication facts memorized, so I said, you know, this is actually an important skill. Her response was so powerful because it summarized so much of what we are dealing with. She said, I know it is, but my son is in the before and after school NEST program. He is at school from 6 a.m. till 6 p.m. Are my husband and I supposed to come home from our long days and after our son has been at school for 12 hours, teach him more because it did not happen at school? Why isn't this happening at school? And she is exactly correct. We don't have 4 minutes in a 12-hour day to do this. So I know this is much easier said than done, but it has to happen. So to conclude, ask 3rd through 6th graders, 3rd through 6th grade teachers, how helpful it would be if students came to their class fluent on day 1. As a parting thought, based on the research I discussed and the data I showed, we are in the midst of a math fact crisis. Thank you.
Thank you, David.
Thank you so much.
Thanks, David.
I am first going to open it for any public comment or questions.
Hello, Cassandra Quaylar, 2nd grade teacher at Elkhorn. As a 2nd grade teacher, I know that fact fluency is very, very, very important. In this district, it's very sad that teachers are having to randomly create their own fact fluency programs, if they even do their own program, because it's not easy to create a program, with no continuity in a district program that develops from grade level to grade level, because our district math curriculum is lacking terribly in this area. So it's something as a district we should really be looking at. Thank you.
Thank you. Any other public comment? Sue?
Hello.
Hi.
Hi, this is Amparo Jauregui Saldana. I'm a 3rd grade teacher at Prundell. And I'm glad a parent has brought voice to something that the teachers have been trying to advocate for a long time. As Ms. Cuellar said, our math program is very old and outdated. As a parent whose students went through Prundell Elementary, as a teacher, as a board member from a previous district, I'm almost going to say that I am begging that at this point, our district please consider a math program that will address the needs of all of our students, and that we make this an urgent matter, because our program is so outdated that I think I was part of that program as a substitute teacher more than 15 years ago. Thank you to the parents that are being concerned and bringing this. Hopefully their voice will be heard more than ours. And hopefully we can urge the board members to have finally a new math program be adopted. I can say my third graders, I'm giving them Fact Fluency. I have 8 of them that are finishing in that 98 percentile that Mr. Margulies was talking about, out of 24 students in less than 5 minutes. And that should not be, because we're close to the end of the year. And I work hard. So I really would appreciate help with a program that brings in fluency at all grade levels. Thank you.
Thank you. Any other public comment?
So I do want to say that we've begun to raise awareness a couple of years ago when I came in 2022, and I identified this gap then. And so I brought from my previous district, I had a 5th grade teacher. She was outstanding. She said, Mr. Chiboucas, I can't teach 5th grade anymore. And she was a stellar teacher. And I said, no, but I need you there, Mrs. Rich. And she said, I can't, because I can't get my students to learn math. Very passionate Brazilian. I can't get them to learn math because they don't have their multiplication facts. I said, what do you want? She said, I want to go to 3rd grade and teach them math, multiplication facts. I said, okay, if I put you in 3rd grade, you need to ensure that every single one of your students leaves 3rd grade with multiplication facts. So a 3rd grade team got on board. And if you look at our 2023 University Park scores, from the year right after COVID, because it's 2022, but it's registered on the dashboard at 2023. If you go to the dashboard, our University Park outperformed. We were the bottom performing school, one of the 2 bottom performing schools out of all 14, but we got the most growth. We got 11.2 post-COVID. The year they just returned 11.2 points up in math, and we got the highest historic growth at University Park. And I don't know if it's the multiplication facts, maybe it's their capacity, their confidence, all of it. I think it's very developmental. And I need to make one more comment. So I brought one of the practices here. We've started it today at our Tier 1 meeting. Our teachers established that we are full implementation of utilizing what we have done. We did bring it to the district. Elkhorn 4th grade teachers used it last year. And Elkhorn grew from 8% proficiency to 28% last year. But what we're doing is it's a temporary fix. What I did is I bought graph paper for every single teacher, grades 3 through 6. And if students are deliberately taught to generate their own multiplication chart and manipulate it from multiplication and division, on the day of CASP, they are allowed by law to generate their own multiplication chart and utilize it to compute to reach those higher level computation, high grade level standards. And like I said, Elkhorn produced Amparo, by the way, on there, she got 41% proficiency of her math students, just saying. But at Castroville this year, we've eased into it. Mr. Margulies came to one of our staff meetings and showed us our data relative to our particular students. And 100% of our 3rd through 6th grade teachers are teaching their students to generate those multiplication charts and manipulate them to access the grade level content. So let's see how it goes this year, because they can use it for division as well. But ultimately, we want to remove that crutch because they need it with automaticity, right? But hopefully it's a temporary fix. But we can't forget about conceptual learning, conceptual understanding as well. That's a big piece.
Thank you. Right. Closing public comment. Julia, do you have any questions or comments?
I just really like the way you explain this to us. A lot of people can think of math as like learning another language. It's just the language of like numbers, and to building those foundational blocks and keeping those blocks in place and building off of them is so important, and addressing that every student learns differently. It's like the same way if English was my first language and I learned Spanish after that. I started off by learning vocabulary words and sentence structures until I started incorporating it into my normal vocabulary. Then I started thinking in that language. And some people have said, they know that they're fluent when they start dreaming in that language. And so eventually, you know, so building that, it's like, it's an instinct, you know, you don't have to think about it. It just happens. So I really like the way you explained it. Thank you.
Thank
Yeah,
you.
I think, you know, when I talk to, I think we're, as a parent, we're so far away from what we did in fourth grade. And I talk to parents, you know, multiplication fact fluency, it's so important. They go, oh, well, you know, why? If I'm doing a tip, I can just use my phone. But that's why when I went to read the research, and that's why I took the time to actually go over those 5 reasons, because was not, you know, aware of those. But when you hear those reasons, it's intuitive that is what happens when you're working. You have limited working memory. And if you're trying to do these complicated problems and your working memory is focused on math facts, how can you think? And, you know, that's just like what you're saying. And so it's important to be aware of that. And there's a huge amount of research behind this. You know, it's not just these things being said and that they make sense. You know, you can study them. You can measure like reinforcement, you know, you can interject easy problems between hard problems, and students will like do more problems because of it. So these things are real and measurable, and, you know, practice, that's an obvious one. So,
Thank you.
Yeah.
Thank you, David. Rick?
Thank you, David, for another great talk and information from you. It was great. We'll definitely have to. I'll email you some more comments and stuff.
Thank you,
Thank
Rick. Sandra?
David.
Mhm.
Well, first of all, I want to thank you for volunteering in a classroom,
Yeah.
day in and day out, working with kids to improve their understanding and proficiency with math. That's amazing because educators, while they're very special, they're not superheroes, and they can't do it without parents, the community, support staff. Really, that's what it's going to take to get our kids to the very next level. And that's what you see in schools that have more money or maybe are highly really organized. There's community support, and there's also community call out when there's deficiencies. And that's what you've done here. I remember the first time I heard you speak, you were so passionate about math. It was almost contagious. And I hate math. Although I can tell you what 25% off of something is really quickly. So I just want to thank you. I think that what you said is this is an area that needs focus. And I think nobody here is going to disagree with you that we want to see our kids be proficient. We want to see our kids be successful, and that you're willing to come up here, put all the time and energy into those slides with a lot of information on it, that you're passionate, you keep on beating the drum. That's what we need to move our district and our students forward. So thank you. I also want to recognize Gigi for talking about the data. How do we, recognize the data and use the data to help our students do better? She brought an amazing toolkit, and now she gets to have her own site. And I'm so excited to see how that site's going to grow, because I know it is. So you're 2 amazing people. I love your passion for math, and this is what we need. So thank you.
Thank you, Sandra. Angelo?
Honestly, that you're here. I want to really thank you for your passion, and also thank you for your patience.
Yep.
You know, it's a little bit of an effort to get from public comment speaking, and, you know more of the process than I do. So I appreciate that you never stopped and you kept going. And like I told people before from the classroom, the majority of my students that struggled didn't have their math fluency down. They were having issues with negative and positive integers, and then I noticed a correlation. The ones that have problems with it wanted to stop taking math after their 2-year requirements, versus the ones that felt comfortable would do 4 years of math. So it's kind of starting to hear that math fluency early in life can dictate choices they're going to make with their careers in the future at high school level. So this is definitely an issue that needs to be addressed, and the best way to address it is when the community gets together, parents get together, and do exactly what you did. So keep it up, and like I said, I'll give you a call soon to talk more about this.
All right. Thank you, Angelo. Martha?
David, we're really glad to hear that. I know exactly what you said. You've been pushing for this. I learned a lot. Thank you for your presentation. And I also want to point out, Julia, you've been just blossoming with your questions too, because we love hearing your feedback because you're in it. You're in front line with it. So I know that this is an area we've been talking for years, about math. Math has been an area that's been our lowest scores for many, many years since I've been a board member. So the fact that I'm hearing this is something that, proven data that works. I know that there was just a town hall meeting, so I can't, we're going to hear from Matt to see what the goals are for our math program. I know you're passionate about moving up those scores. We just talked about it. That's one of the things that we're holding you accountable for. So everybody's passionate about this, David, and we know that we're here to work together and give the support that everybody needs to move that needle. So hearing you as a parent, hearing the student voices, hearing some of the voices from there and the importance, and Gigi, thank you, for that collaboration and working with David on this. So I'm looking forward to see what the next steps are.
Thank you, Martha. Dr. Turkey?
David, first of all, thank you very much. David and myself met, multiple times going through this and that sort of thing. And that was, first of all, it was fun geeking out together on things, right? We talked about R squared. We talked about correlation versus causation. I got to pull out my thesis and that sort of thing. It was pretty fun. We got to geek out together. So that was great. So we can't underestimate the importance of math fluency. We can't. And as I always say to David, fluency doesn't work on its own. We actually have to pair it with application and conceptual understanding, but we cannot disregard fluency, right? Conceptual understanding and application don't stand without fluency in the same way that fluency doesn't stand with application and conceptual understanding. So the three go together. And David, thank you so much for your presentation.
Definitely. Thank you, David. Thank you for volunteering. I think it takes a lot of dedication to be constantly volunteering and constantly coming and talking to us of things that we need to improve. And I look forward to us having a good discussion on how can we make things better for our students and for everyone, and the dedication that you have to make sure that every one of our students succeeds. I applaud you for that. So thank you so much. And thank you for the presentation.